Hi, in this short video I am going to demonstrate how you can achieve a delegable content search in Power Apps with a SharePoint list. You heard correct, Power Apps with a SharePoint list and no delegation issues. Let's do it. Hi there, my name is Jared Simpson and welcome to my channel where I hope I can help you in your Power Platform journey. A content search is such a powerful feature to have. It allows users to pinpoint a single record or a small subset of records with words that appear in the middle of a text string. However, the out-of-the-box expressions used in Power Apps for a content search are not delegable when using SharePoint as a data source. Today, I'm going to share with you how to achieve a delegable content search experience in Power Apps with a SharePoint list data source. Okay, let's have a look at the delegable content search experience in action. On the screen, we have a simple gallery which is bound directly to your SharePoint list NA Highway Networks. This list has upwards of 70,000 records, which you can see here in the site contents for the site. With no text in the search box, the gallery just shows the data source. Now you will see as I search for a word, the results display for records where that word resides anywhere inside the full string from the name field. It also works for multiple word searches. As you can see, this allows me to isolate multiple records throughout the entire dataset, right up to greater than ID number 70,000, regardless of where that search term resides in the string. So how did I achieve this experience? Well, we know that starts with on a text field is delegable. If only there was some way of carrying out a starts with query on each word within a string. Well, guess what? With some string manipulation and adjustment to your data structure, this is possible. You can perform a starts with query on each word within your original string, all of which can be delegated to SharePoint. Let's look behind the scenes to see how this was achieved. The first thing I should point out is the field in the SharePoint list that we want to undertake the content search on is the name field. We will now configure the data source. So we go into our list and we create additional single line text fields. These fields will be used to hold the various substring elements derived from the text entry in the name field. The number of additional fields will depend on your use case. In this demo, I have gone for 9 additional text columns, giving me a total of 10 text columns to query, including the original name field. Once your additional fields are created, an important step is to ensure that your columns are indexed in SharePoint. You can do this by going to the list settings, scroll down to indexed columns, select create an index, and then just select create a new index. And just do this for each of your new text fields. This will help SharePoint more easily find your records when it is searching through and executing your query. Now let's move over to the app to see what's happening there. The app is a simple configuration which comprises these main controls. A gallery which displays the ID field and the name field for each record. Above the gallery, we have a sort icon, the search text input, reset icon, and a row count on the number of items in the gallery. To the right, we have a form, which is only showing the name field data card. There are other hidden fields, which I'll come to in a second. Lastly, we have our button to submit new or updated entries. So how do we extract the various substrings from the text entered in the name field? This is achieved in the form, and this is where the hidden fields come into play. If we go to the tree view in the app and expand the form, you will see that the form has 10 data cards, one for the original name field, and 9 others for each of the substring fields you will recall from the SharePoint list. Before we look at the code, let's see these hidden fields in action. Let me just make these visible. Just watch what happens when I add text to the name entry field. As I add words to the name entry field, substrings begin to appear in the subtext fields. The current arrangement is configured to put words 2 and 3 in substring 2, to put words 3 and 4 in substring 3, 4 and 5 in substring 4, and that pattern continues for all the substring fields. When the Submit button is selected, all text entries, including the invisible derived subtext fields, are written to the data source via the update property of each data card. Now let's have a look at the PowerFX code used to derive the substrings in each subtext field. We will take a look at subtext 2 as an example and look at the text input control called datacard value st2 inside that data card. The first thing to note is the use of the with function. The with function syntax comprises the scope and the formula. The scope is a variable record and the formula is where your main expression goes. The way it works is your formula can use and reuse the parameters from the variable record set in the scope. One of the main benefits to this is it helps keep the expression concise where you need to repeat certain inputs, which is the case here. Another key feature is the variable record entered in the scope is only available within the context of the expression and cannot be referenced outside the expression. The good thing is this expression is the exact same across all text inputs, the only exception being the integer in the var number, i.e. var no property of the variable record. As you can see, when we look at a couple of other fields, var number is the only value that changes. So this is easy then to replicate in your app. So the first thing here is to set our variable record with properties varw and var number, var no. varw is a single column table created using the split function on the full text entry and the name text input called datacardValueName.text. So if we look at the syntax, the text to be split is datacardValueName.text and the separator we're using as the split point is a space, i.e. the space between each word. So when we type multiple words into the name text input, it splits the string up at each space and arranges this into a single column table. Notice the column header is named result. In the scope of the with expression, this table of substrings then becomes the property varw in the wider record. Secondly, we set the variable property var number as an integer. This value is set to equal whatever substring field number you're on. So in this case, we are on substring field 2, so we set var number to 2. And this is the only value that needs to change when replicating this formula in other text inputs. Now before we go through the main formula, let's just have a quick look to see how using with function has helped us here. If you count the instances, each property from the variable record has been used. You can see each has been used 5 times. This is a really good demonstration of how useful this function is, where you can declare once and use at will within your main expression. What this if statement does is it carries out 2 logical tests with corresponding true values. The first logical test counts how many rows are in the array of substrings and checks if the count is greater than var number, which in this case is 2, as we are in substring 2 field. If it is greater than 2, this means the array is at least 3 rows long. And in that case, the first logical test resolves to true. This then concatenates the second and third values in the array, i.e. the second and third words from the original string. and renders this new substring in the text input for this field. I should note here the use of a brand new function, index, which I picked up from a tip shared by Reza Durrani a few days ago. Traditionally, selecting a row in an array is achieved by a combination of last and first n. But index now tidies this up, and this has helped me tidy up my code in this app, so cheers Reza. If you move then to the second logical test, if the count equals 2, there are only 2 words in the string, and the true value here then is just to grab the last value in the array, i.e. the last substring, and only render that in the text input field. If none of these logical tests resolve to true, nothing happens. The text inputs remain blank. Something I should point out here is this is a declarative function. In other words, it's always listening for changes in the text input control text property. As soon as those changes happen, this expression is pulling the data through in real time, much like how you would see instant updates to calculated fields in an Excel spreadsheet. This expression is applied to the default property of the text input control in all substring fields, with the only parameter changing being var number. Once we are done, we can hide these substring fields, and submitting the form slots these into the corresponding substring fields in your backend SharePoint list, making them available to be leveraged by your searching query. So once we have our data structure adjusted and string manipulation formulas added to create our substrings, we will now turn our attention to the searching query. I should clarify, while I'm using the term search, we don't actually use the search function. Here we have our formula and the items property of the gallery, and it's a straightforward filter of our data source NI highway networks. And the logical test then checks if the original name field starts with the text property in the search text input, or substring 2, which is words 2 and 3, starts with the text property in the search text input, and that is replicated across all the fields. It checks all the relevant columns, and as we're using the OR operator, it will display all the results where the starts with function resolves to true for any column. I will demonstrate this now by searching my surname, which I know appears at various positions in the string in various records. And as you can see, the results are well spread across the dataset. And then if I add another record, which will be the last ID in the list, and do a search, you will see again this contains search in action, delegated to return the very last record. There we have it. Today I've demonstrated how to achieve a delegable contain search when using Power Apps and the SharePoint list. We've covered some key principles of delegation. I'll put a link to some useful delegation resources below. We've had a look at the benefits of using the with function, not to mention the use of the new index function, which is hot off the press thanks to a recent tip from Reza. The last thing I would say is, like all efforts to circumvent delegation, the approach I've showed you today is another workaround. That said, I found it to work really well, and I will continue to use it going forward as a way to achieve that fully delegable contained search experience. I hope you found that useful today. I would really love to hear from you in the comments if you're using this in any of your own apps, or if you have any thoughts on the video. We'll leave it there for today, but if you've enjoyed the video, please hit like and subscribe, and I'll hopefully see you in the next one.